Brilliant. Brilliant. Thanks for the warm welcome. Thank you to you guys for coming today. I know there's quite a few decent talks on at the moment, and Android security can be a little bit niche. But what I've tried to do today is use that kind of like jungle analogy to sort of talk about the kind of Android kind of ecosystem and some of the kind of threats and risks. So that's the kind of the idea behind the talk. I've kind of split it into sort of two halves to sort of to allow for the fact that this is a conference for all developers and technical people. So like the first half is more generally for everyone, and hopefully we can sort of talk about the ecosystem and sort of dispel a few myths. And then the second half we're going to get into some full-on sort of survival tips, some tips to sort of really strengthen the security of your apps. You may notice some references to a certain jungle movie throughout the presentation. There's prizes at the end, if you can guess which one it is. Before I get started, let me just kind of introduce myself in a bit more detail. I'm a lead Android developer at a small kind of apps company based in Bath in the UK, and I work remotely for them from Bristol, which after chatting to a few people yesterday, no one was really kind of knew where that was. So it's about 100 miles west of London, and it's the home of Banksy, and those two things people seem to sort of get whereabouts it is. And so at Intohand, I sort of create apps for all kinds of industries, weather apps, retail, video on demand stuff. And sort of my favorite bit, or the bit I kind of get excited about and enthusiastic about, is the security part, making them harder to hack effectively. And that kind of interest led me to co-author the Android Security Cookbook. I wrote about a third of that book, all the kind of defensive and sort of protection chapters. So some of the stuff we cover a bit in the sort of second half, it will be kind of, it's brief in the slides, obviously, and there's a lot more sort of code samples and stuff in the book. And the last thing I thought would just be worth mentioning is that I co-founded SW Mobile, which is a kind of mobile developers meetup group based in the southwest of England. And we have about 600 members, and we sort of do regular sort of tech talks and hackathons. So even though kind of I work like I'm a remote worker, I really enjoy FaceTime with fellow developers and sort of sharing war stories and stuff. So please do come and say hi after the talk. So I want to kind of set the scene with Android. Earlier last week, Sundar kind of announced that we now have 1.4 billion active Android devices, users of Android. And that's kind of 30-day active. That's devices with Google services installed. So that doesn't include all those, Chinese tablets and things like that. But that's like a huge number. So it's by far the largest mobile platform. And what this kind of funky kind of graphic is trying to illustrate is that it's a diverse platform. There's over 1 million lines of code in the Android open source project. There's thousands of different devices, which this graphic is trying to illustrate from the opensignals.com sort of annual fragmentation report. And there's hundreds of OEMs. So in theory, there's lots of eyes on the code, so they should sort of build a level of trust. But for sure, what there isn't is a single point of failure. There isn't we're not reliant on a single company or entity that holds kind of all the keys. And the kind of point of these kind of couple of slides is just to say, there is no absolute kind of way it is on Android, and that you should be skeptical of any security vendor or company that kind of says they've got kind of a handle on it. But kind of unlike iOS, where we've got like updating devices in this kind of diverse environment via over-the-air updates, when we've got different OEMs and different like carrier modifications, just over-the-air updates just don't work. So, how does Google kind of help with security in those instances? One of the things they do is they build in security services. I just thought I just picked out a couple that I thought were relevant. The first one being, and the one probably most of you have heard of, is the Google Play Store. There's been a human involved in the approval process since the beginning of 2015. And there also, when you sort of sign up for accounts, there's all kinds of background checks that you kind of don't really know about. But Google kind of leverage their other kind of apps like your Gmail and things like that, and all their kind of data points to sort of help with that background validation check. They've also started this developer security notification. So when they're scanning the apps and running their kind of tests to see if it's not malware and stuff, if they detect things like the developers have accidentally included their private keys in the app, if they're using a vulnerable version of OpenSSL that they've included, and there's some issues around particular versions of PhoneGap called over. And what they started doing was, notifying developers saying, hey, you've got your private keys in your app, you should update that. And they reckon there's about 60,000 apps have been updated on the sort of back of those notifications. So it's a pretty good sort of system, small drop in the ocean compared with the number of apps, but it's kind of a step in the right direction. And the other kind of thing that is kind of behind the scene and on Google Play Store is the Android Bouncer service, which was announced or publicly announced several years ago. And that goes and sort of runs all the apps in sort of emulated environments and checks for sort of malware signatures and sort of dodgy stuff, and then removes them from the App Store, suspends them, and if warranted, can remotely wipe them from the devices. The other kind of thing in terms of security is the Android Device Manager, which is a free service that anyone with an Android device can install, and that help you find, lock, and if necessary, wipe your device. So if you've got an Android device and haven't got that installed, I certainly recommend putting that on. And something that Google has announced kind of recently is the safety net sort of system. It's like an intrusion detection system. Any device with Google services kind of gathers various different data points and sort of uploads that to the Google services, and they do some like big data analysis. That's what they do, and they try and look for potential malware and things like that. In the second part of the presentation, I'll talk about there's a public API for SafetyNet that you can sort of leverage in your apps to sort of leverage some of that kind of knowledge, which is pretty good. And lastly, I just wanted to mention sort of Android at Work, which is a way of segregating your personal and business data and applications on the same device. It's definitely geared up towards a BYOD type approach, but it gives system administrators API access, for provisioning and things like that, managing profiles and stuff. What's really cool about that is that you can your work can sort of remove your access and just wipe the business data and apps, and not your personal photos and stuff, which I think that's pretty cool. The next sort of slide talks about the different layers, and I sort of stolen this from Adrian Ludwig's talk from Black Hat, because I thought it was quite good at showing the different layers. And it kind of, if you go from left to right, that's the kind of more cloud-based services, and then to the sort of layers within on the device. I just wanted to draw attention to the verified apps kind of section, which is something that came into Android in 4.2, which was a way for Google to sort of monitor apps and detect potential malware when users were installing like applications not from the Google Play Store. So for anyone who's got an Android device and has installed that, you'll see like the verify apps consent, and then hopefully maybe some of you have seen that when it's some potential malware, you'll get a warning, and in fact, if it's sort of so dangerous that you could be blocked from installation. So I think that's a pretty cool check, that the way that Google are trying to sort of increase your security, even though you're not using the Google Play Store. The other thing that's worth bearing in mind is Android sort of upgrades and gets newer. Then the newer versions have more security features and are stronger. I thought I'd just mention that from if you're looking for a BYOD kind of policy point of view, mandating newer versions of Android would be a good policy, as well as if you're certain for certain apps, if you need certain security requirements, then targeting say 5 and above would be a good call. So that's kind of like the ecosystem kind of bit, and I wanted to talk about some of the threats now. And so malware is kind of like and Android security in general is one of those things that always gets the tech media love to get hold of. I'm sure you've all seen those clickbait headlines that about how Android's been ripped open again and again, and a lot of that stuff is as you kind of learn more about it, you can see actually it is a lot of hype. But that said, there has been more publicly disclosed malware on Android than say iOS, and it tends to be around largely kind of around sort of like premium SMS sort of driven. Although in Android 4.2 we got this new kind of warning, so if you text a shortcode, you get like a user confirmation screen that comes up. So that has mitigated some of that kind of malware. And apart from that, it tends to be more kind of information stealers, and actually recently we've seen sort of like more ransomware type things. But the last thing I just wanted to say on malware is just the regions where you are in the world plays a huge role. So like Russia, China, and Persia, the average instance of malware is like a lot higher than sort of Europe and America, and that's kind of something that as far as Google have announced they're sort of looking into, but that's something to sort of bear in mind when you hear these kind of stories about malware. One of the other kind of threats that we have is app hijacking, and this is also known as like Trojanizing apps. And so the idea is that you take a genuine app and then you decompile it and you put some malicious code in there, and that obviously is going to can potentially damage your brand if that's your app and affect your users. And the idea is that you dupe users into installing that from phishing emails or something like that. And so the concerns around this is because reversing Android apps is pretty easy. There's a talk this afternoon which covers some of this, so I'm not going to go kind of into too much detail now. On Android we don't have like a certificate authority when we're signing apps. So for those unfamiliar, each app has to be signed for it to be installed on a device, but there's no kind of central authority around that. So they're all like self-signed certificates, and the other kind of concern is that side-loading apps, which is just installing apps that are not from the approved Play Store, is very simple. It's just an option that you turn off on the device. So those kind of like three things that make app hijacking more of an issue than say like on iOS, where it's a lot more difficult to sort of say to sideload apps. We'll talk in part 2 how some of the defenses you can put into your app to sort of guard against app hijacking. But there has been a couple of big stories. In fact, I could probably do a presentation just on all the security incidents in the last 18 months in and around the internet and Android. Although Heartbleed that I'm sort of talking about here is only really affected one version of Android, it was still sort of affected anyone that bundled that version of it. Was to do with an open SSL vulnerability, and part of the developer checks the Play Store does now, the app scanning was related to this kind of this threat. And recently, as you probably guessed as well, you have to come up with if you come up with an Android exploit or a thing, you have to come up with a cool name and a cool logo, and everyone's doing a great job at that, which is great to see. So stage fright was another one that affected almost all Android devices out in the marketplace. It was a widespread exploit potentially, but and it could deny the service attack that device, but actually there hasn't been any kind of threats, or hasn't been any kind of attacks as yet. I thought I'd mention this, A, because it's recent, and B, because off the back of it, some really positive things happened. So like, Nexus devices now have a monthly security update and security bulletin with all of the things security issues have been patched, which is awesome. And Samsung and LG also have committed to more frequent security patch program. So it's on the light of these, this great research that was done to find this, and this kind of funky name that got all the media's attention and stuff, and that's kind of forced some of the OEMs to sort of really increase their security updates. So I think that's a great thing. So that's a couple of the threats. Let's talk about some of the kind of risks to our applications when we're creating them. And of course, no presentation can be complete without a top 10 of something. So I thought I'd mention the kind of the more standardized kind of top 10 risks that there are to our apps, and this was compiled by the OWASP project. Some of you may be familiar with the Open Web Application Security Project from the web world. It's a not-for-profit organization which is kind of focused on improving security in software. And a couple of years ago, they produced the top 10 mobile risks, and I think they're due to update that very soon for this year. So when we're talking about some of the survival tips in the second section, we'll kind of try and relate back to some of these. I've sort of just put them here for your reference. It's too much to sort of take into on a slide, but if you go to the OWASP site, the mobile security project site, each of these is broken down in terms of like attack vectors, and in some cases, sample code of how to sort of mitigate them. So definitely worth checking that out. And this, I would say, is one of the things that you should look at when you're doing your development and testing and things. If you can sort of tick off these kind of 10 risks, then you're on a good sort of path to making your app more secure. So this is the sort of part 2 where we're going to dive a bit deeper. I thought I should just get a quick show of hands. Who's an Android developer in the audience? Okay, brilliant. That's awesome. That's way more than I was expecting. Cool. So you guys are going to love this stuff. And even if you're not an Android developer, a lot of this still applies to sort of iOS. So when I'm going to talk about some of the or any kind of mobile thick client, effectively. Yeah, let's look at how we can sort of survive in this kind of jungle and sort of improve our app security. I was going to focus on these kind of 4 areas, and each area is kind of we've got several kind of things in each bit, but really we want to harden the network communication between the app and our servers. We want to protect any data that we have stored, and what I mean by this is we're going to use encryption for that. We look at ways to validate where the app's running, the device integrity, and also the app's integrity. And then we're going to look at how we can increase the binary security. So as I say, a lot of the things we talk about apply to iOS as well. So I thought I'd start with strengthening network communications, because I think pretty much every app that I've written has some kind of online component.
So it's almost like goes without saying, but using SSL and TLS for all your network communications should be a default. I really like the fact that in iOS 9 they've made that a sort of mandatory thing, and you have to sort of opt out of that. And I hope the next version of Android comes with something similar. Um, uh, the second point I wanted to make is to use the platform SSL TLS validation and not to disable it. That sounds like almost like a stupid thing to say, but if you look at if you sort of Google or go to Stack Overflow how to enable using self-signed SSL certificates, you'll see that the most voted answer on Stack Overflow with like tons of rep tells you how to disable the SSL validation. We're totally rendering the point of having SSL useless. Um, there's different ways of doing it. You can use a form of pinning, which I'll talk about next, or you could just buy genuine certificates for your development servers. That's what I've done in the past. It saves you having to put all this dodgy code in into your code base that basically turns off the validation. Um, the other thing you could do is to only use the stronger cipher suites and the stronger TLS versions. This is particularly important or useful if you control the servers, then you can control the type of connection and the strength of the encryption between your apps and the server. And often a lot of SSL kind of defaults to like lower versions to support older browsers. But you don't have to do that in your app. You can sort of enforce that. And if anyone's using OK HTTP, 2.1 saw quite a few cool security updates and features. But if you're using 2.1, there's a good article there on how you can enforce the connection spec to be a lot stronger and to drop the sort of lower specs. If you're using just straight out the SDK. HTTP URL connection, HTTPS URL connection, sorry. You can still do it with that as well. And if anyone wants any code samples of that, just give me a shout. But yeah, it's like a one-liner on OK HTTP. The other thing you could look at doing with your connections is using SSL pinning. If I could just get a show of hands, who's heard of SSL pinning before? Okay, brilliant. Okay, so most people. For those that haven't heard of it, it's just a kind of way of kind of reducing your risk of man-in-the-middle attack. You're reducing the amount of certificate authorities that you trust, and you're kind of just like effectively pinning your SSL certificate to make sure it's that one. And there are two different types of pinning. You can pin the whole certificate, or you can pin the public key of that certificate. And I would always recommend doing public key pinning. For the main, it's a slight extra step in getting the pin, but you don't have to sort of change your app or force an app update every time you renew your certificate. And I've put a link to the book there. There's a code sample of how to do that. There's some open source code online by Moxie Marlinspike, but it hasn't got a great commercial license. But yeah, check the stuff out in the book. But in essence, it's just a way of when you make a connection, you just do some validation to make sure it's the SSL certificate it should be. That's the basics of pinning. The other thing you should probably look at doing, and this is the kind of last bit on networking, is that as part of the Google Play services, they've introduced this like a dynamic security provider. This is another one of those things that because we can't guarantee over-the-air updates, we can't guarantee that users are going to upgrade their phones. This is one of the things that kind of Google have put in place. And the update cycle of Google Play services is what, like 6 to 8 weeks. And so for in that time period, there's a chance to get, if there's a vulnerability that comes out or an exploit, then there's a chance that fix gets bundled within the Play services. I've put a link to the training article there. That's got all you need to know about how to call that and when to call it. But I just thought that, the code sample, that's it. It's that simple. And you can actually use that. So that provider will fix any issues in the system that has with any of the OpenSSL libraries and things like that. And actually, because it's an update of the cryptology provider, you can actually use that for your when you're doing it just standard sort of encryption as well. So you can use that instead of like bounce a castle. Yeah. So that's kind of it for networking stuff. I wanted to talk about sort of data next, and I guess when I say kind of storing data, I mean kind of encrypting your data. And something that frustrated me as an apps developer when I had pen test reports on the apps that I'd created, or spoke to security sort of people, analysts, they always said, "Oh, don't store data." And I'm like, well, I want to make my app as performant as possible. I want to make it work. I want to make it work offline, and I want to make it kind of work in sort of over dodgy mobile connections. So the whole kind of very abrupt, just don't store data, just always used to bug me. And so, but if you are storing it, it needs to be encrypted. And obviously, this totally depends on the type of data and the type of application you have. Probably medical records, nuclear launch codes probably shouldn't be cached, but other data should be. Yeah, and so I thought I'd just jump in with some code just to show how kind of easy it is. And this is a kind of like best practice approach when you're doing kind of encryption, is to use like password-based encryption. And this is a way so you don't have to store the key anywhere. Because the main thing about encryption, or the issue is what to do with the key, where to store it, and it's rarely the algorithm that's broken. It's the fact that someone finds where the keys are. So this just shows you how to use. So password-based encryption is a way of using something the user inputs, and then using that to derive an encryption key. In this case, we derive a symmetric encryption key. So that's a key that we use for encryption and decryption. So I'd put this in for reference. There's a better example and stuff in the book. But the idea of this is, you don't persist the key anywhere, you don't log the key anywhere, and then you build in like an app timeout or something, maybe depending on your app, maybe when the app goes into the background, maybe when the user logs out, but you'd wipe that key from memory, and that's how it sort of stays safe. And the one point I just thought I'd mention about this code sample is that we're using like 10,000 iterations, which makes it like nice and strong, but it does take a long time. About 5 seconds on, maybe 4 seconds on a Nexus 5. So that's a pretty lengthy operation, but you can tune that to depending on how how secure you want it to be. I thought I'd also mention a couple of libraries that can make your encryption tasks a lot easier. All these libraries are commercially viable, otherwise there's no point in mentioning them, to be frank. Also, the slides that are uploaded have links and stuff to all these. So Conceal is from Facebook, and it's really awesome for files. They use it for encrypting photos that they've cached on your SD card. And so it's really easy to use. It defaults to all the kind of strong algorithms and stuff. It uses AES GCM, which is the kind of preferred AES algorithm to use. It's really good. I definitely recommend trying that. I say it defaults to the strong stuff. That's because the stuff, whether it's a kind of hang-up from the Java days, but from Android's past, being Java-based, but the default when you're dealing with encryption, it doesn't default to the strongest kind of algorithm stuff, and that's, I think, quite a shame kind of going in, because you just want
just want to start using it and it be as strong as possible. But that's what's nice about Conceal. SQL Cipher, if any of you have a SQLite database in your app, which you use for data storage, you can very easily swap in SQL Cipher. The API is all exactly the same, apart from when you open a database and when you create a database, you have to pass in a password, and it uses that password-based encryption that I talked about a couple of slides ago to sort of generate a key and encrypt your database files. So I think that the key thing about these libraries is they're very easy to use and they're very easy to swap in and out. That's sort of what gets kind of big ticks in my box. So SQL Cipher uses like 256-bit AES in CBC mode, so it's pretty decent. The only kind of gotcha with SQL Cipher is that it adds about between like 4 and 7 meg to your APK size, which for some people that's too much. On the kind of the good news is that Google just upped the APK size limit in the Play Store to 100 meg, so hopefully that gives less excuses not to use it. And lastly, I just thought I'd mention secure preferences, which is one of my open source libraries. You can also look at Hawk, which is a much better named and a much more popular implementation. But the idea is so secure preferences, for those who aren't familiar, is just a key value store which is backed by an XML file. It's just a very easy way of kind of securing or obfuscating those files. So people on rooted devices can't go and mess with the settings. So with secure preferences, you can use it with a password, and it does that password-based encryption, and it's nice and secure. If you don't use a password, it will generate one and sort of store it in there. So if you rip the file out, you can't tell which one's the key, but it's still obfuscated because it's still just obfuscated because you could find it with enough effort. But the idea, it's just like small steps to sort of make your apps like harder to hack. But above all, you really should avoid hard coding your encryption key. Like I kind of mentioned, reverse engineering and finding like a string constant for your encryption key is trivially easy. But I can totally appreciate not all apps can sort of use the password-based encryption, an app passcode or something like that. So if you have to, at least generate a key dynamically per installation. Don't hard code it, because it's the equivalent of locking your front door but leaving the keys in there. Yay, the door's locked, but you've got no security at all. So hopefully you guys remember those two. So let's go on to verifying the integrity of the app. So there's a couple of things you can do. You can check. So this is to try and work out whether these are tamper detection techniques effectively. Has your app been hijacked? Is it running in a different sort of state? So you can check. You can talk to the package manager and see if you're in a debuggable state, which shouldn't be happening once you're in production. You can calculate an APK checksum to see if anything's been modified, or you can do a signing certificate verification. And this is kind of my favorite one. Because I kind of mentioned earlier, each app has to be signed with a developer's key when we publish it or when we distribute it. That key remains the same for the lifetime of that app. And one of the kind of cornerstones of Android security is that the signatures have to match. So I can't just take Facebook's app, decompile it, which would break the signature, re-sign it, and then distribute it to you guys, and you install Scott's version of Facebook. It doesn't work that way. It wouldn't. The signatures wouldn't match. It wouldn't let you upgrade. So your signature stays the same throughout the lifetime of your app. You know that in build time, and so you can check this in runtime. And this is just really quickly how you do it. You would
use like key tool, which is just a Java tool, to sort of list out your key store's key, the signature. Then you just embed it in the app, and then at runtime, you'd go and again ask your friend, the package manager, for your signature. Hash the signature and to a SHA-1 to match what you've embedded, and then just compare the strings. And that's a quick and easy way of detecting whether your app has been decompiled and then changed. However, of course, if someone can decompile our code, they can take this check out. And what we'll cover in a couple of slides' time is how we can obfuscate our code and make this harder to do. I think that's probably it. You can set that for anything we put in the app. The SSL pinning, the encryption. Someone can decompile, take bits out, and look at it. But it's using all these methods in conjunction with each other that sort of hardens the app. If we want to verify the device integrity, there's various different things you can check in the build properties just to see if it's an emulator. You could just there's a couple of good answers on Stack Overflow. Tim Strazier has a really good library on GitHub, which goes through a load of stuff which actually has been inspired by the different malware that he kind of encountered as a security researcher. So that's quite a cool library. Again, you should be running in an emulator if you're in production, so it could give an indication that this app installation that's running is you're being kind of tampered, or dynamically debugged. The other thing that you can do is the safety net test, and this is kind of what I mentioned near the beginning. So there's as part of Google Play Services, I think it was 7.5 that it came, that it was released. There's a test you can run, which if the documentation's a bit kind of vague about what it does, and if you look at the actual variable that comes back it says whether it's CTS compatible, and the CTS tests are what you kind of each version of Android that's kind of built from the open source tree is kind of like, if it passes all then it's verified as an okay sort of device. But actually, the safety net gives us, will come back false if the device is rooted, if it's been compromised in other ways, and it's got other vulnerabilities. So it's quite it's an interesting way that you can sort of, check the state of the device. I thought the API was quite unwieldy, so I wrote a helper library to sort of wrap that. That does the on-device validation. There's a sample in the Play Store as well that you can just run on your own device. But it gives an indication that app installation could be running on a compromised device, and you can act accordingly on the server depending on that information. The sample library doesn't have a server-side component, which the Android security team let me know that's what it should have. So you do the validation test on the device, which is good, but it's better to do the validation tests on the server. So because that can't be compromised, because that's could be. But the idea is that if the device is owned, then you want to do those checks on the server. So it's kind of like it's got enough to get you going with that, and then I'm working on a sort of server-side branch of that to sort of to show how that can be used. But yes, worth checking out. And the other thing that I commonly get asked is detecting root, and that's kind of thing that you might want to do in your app. And there's no. I should probably start with a disclaimer that there's no 100% way of checking for root. If the being root on device is equivalent to being God, so there's no way you could ever 100% say that you've detected it or not. But what you can do is you can look for root apps. You can look for potentially dangerous apps. You can check certain system properties which will have been could have been changed on a rooted device. The most common way is to look for the SU binary. which may or may not be present or may be hidden. Same with the BusyBox binary. You can also check to see if certain system paths are writable or sort of read-writable, whereas when they shouldn't be. And what I did with a colleague of mine, we sort of pulled together a load of those checks and put it into a library called rootbeer, which the handy logo at the top. But that sort of does a native check as well. And we managed to defeat some of the root cloaks that we found. But if you install like several root cloakers, like they managed to defeat it eventually. But yeah, it's a good reference. And if anyone's got any other kind of root checks they want to add to that, that would be awesome. But yeah, that's a quick and easy way of doing it. So as I said, with a lot of these this hardening, these security features, we need to sort of look at ways we can protect the binary to sort of to make it more difficult for attackers to sort of take those checks out, those things. So what we can do is we can obfuscate the code. And for those unfamiliar with obfuscation, it's just a way of turning your nice, easy, maintainable code into kind of what we see in the background here, gobbledygook. It's harder to reverse, but it is what people kind of refer to as security via obscurity. It's not like your code's not encrypted. It's just harder to read. And hopefully most of you have heard of ProGuard. It's kind of the Java obfuscator. It's part of the Android SDK. It's free, and it's very easy to turn on effectively. And a lot of the Android exceptions that you have already been. You've already got it installed if you've got the SDK installed. One of the things you have to remember when you start using obfuscated code is that if you get crashes, I know that sometimes happens in apps. I can't say I've ever written an app that crashes myself. Line mode cancel. But trying to work out what's gone on with the stack trace that's been obfuscated is near impossible. And that's why in ProGuard they have a tool called retrace, which takes the output from ProGuard, which is like your mappings file, and you can use that with the tool with your stack trace and turn it back into a sensible stack trace with line numbers and proper names to your classes and methods. The awesome thing is that services like Crashlytics, Hockey App, and I want to say Criticism, but I can't remember if they do now, support automatic deobfuscation of crashes. I'm a massive fan of Crashlytics, so I've used that the most. So I'll just talk about that. They have like a Gradle task that runs when you do a build, and it will upload that mappings file. So it does it automatically. It's really handy. But if you want to sort of go ProGuard, you want to look at something called DexGuard. There, of course, this is the pro version, the paid version. Of course, there are other kind of obfuscators which you could look at. Meteophoric have one, and Arcsan is probably the other one that's very popular and expensive. But they do a much more a better job than ProGuard at protection. So I'm most familiar with DexGuard, so I'll talk about that. The difference between it and ProGuard is that this ProGuard's a Java obfuscator, whereas DexGuard has been specifically built for Android, and it's more around protection. There's actually some cool security utils built into the enterprise version that you can do some of the stuff we talked about in this presentation just using the utility code, and that's automatically sort of hardened as part of your part of the process. But just like helper utilities, effectively. I just thought I'd mention my two favourite features, which is string encryption, which is perfect for any kind of API keys or secrets that you have in your app. And these are the things that when you reverse engineer, it's so easy to find, and it's kind of like how do I stop people from getting hold of that? using string encryption as a way of doing that. And this is just where in your DexGuard configuration file, you just define those strings, whether they be the actual variable name or the code. You have lots of different options there. But then whenever that appears in the code, that's all encrypted. And it's obviously the keys in the APK files somewhere. Otherwise, you wouldn't be able to run the app. But it's just like a quick and easy way of kind of hiding those your keys and things like that. The other one is API hiding, and that's a way of part of the kind of DexGuard process. It kind of changes anything that's been hidden into a Java reflection-based call. And that, when you reverse engineer it, is a lot more difficult to find out figure out what's going on, the flow of the app. And what you can do is use those in conjunction with each other, and that's why I kind of like them, because you can, say, hide your tamper check or hide your SSL pinning verification, and then using string encrypt reference your method name, your class names that you've used a reflection-based call on effectively that you've hidden, and that's also encrypted, so it sort of makes a double strength check. So anyone that's kind of looking for that is looking at some code that doesn't make any sense, but also it's looking at something that they have to then decrypt first. Yeah, I think it's pretty cool. That's kind of it for the sort of survival tips. I just thought it'd be worth mentioning about sort of testing and sort of trying to see the other side of the coin. As in what the attacker sees. There's so many tools and great articles about how to reverse engineer. Things like APK tool, DexGuard, AndroGuard. But I just thought I'd mention two tools, one that's new and one that's been around for a while. The Quick Android Review Kit, which I just can't help but think Quark, and that's just how I say it, and that's the face I see every time I see that library, is fairly new. It was open sourced a couple of months ago by LinkedIn. And this is just like a Python script that you run against your app or your source code, and it'll give you like an HTML report about the weaknesses or any exploits that could potentially be done. And the cool thing, it generates like an exploit APK that you can then install on this device and then try and exploit different things. So it's definitely one for your testers and for you to do once you've put some of those survival tips in place. It's a new library. They're looking for more exposure, so I thought I'd mention them. And the other one I just wanted to mention was Droser from Mercury Labs. That's been around for a while. It's very kind of feature rich, and that's got lots of stuff. And there's lots of actually the guy who wrote the book with. He wrote some really good stuff on how to sort of exploit and test your apps to see whether they're vulnerable using Droser. So definitely worth checking out. I thought I'd just put a load of links because obviously there's we had time for to mention 4 main areas, but there's tons of other stuff you can look at. There's just some links there which would be useful. And just as I kind of wrap up, hopefully the analogy of the jungle wasn't too contrived for you guys. The ecosystem is diverse. There's predators and threats out there, and hopefully, I armed you with a few survival tips that we can, beef up your app's security. So, thank you very much to GOTO Copenhagen for inviting me here. My company Intohand for sort of supporting me doing this, and 20th Century Fox obviously for not suing me for blatantly ripping off loads of their screenshots from their films. But yeah, and thanks to you guys for listening. Cheers.
Okay, thank you very much, Scott.
Thank you.
There's just a couple of questions here. I guess you better fill them yourself.
Okay. You're saying not persist the key on the device. How do you deal with password change? Or you can do that if you want to see an example of how to do this. Check out my secure preferences library because I handle that in that, and I just do that in a very dumb way of just decrypting the library, decrypting the code that you've got,
with the existing password, and then encrypting again with the other password. You can't cope with so that copes with password change. It doesn't help you cope with if someone's forgot their password. In that case, you can't decrypt the data. So that's why I see it more as it's really good for for caching the data. But yeah, there's no way of getting that finding that password. That's the point. That's why it's the secure way of doing it. And there's another question about are JavaScript bindings in WebView safe to use? That's a good question. I don't know if I have a definitive answer on that. I would say no. I would err on the side of caution. I've always been scared with the amount of what you can do with that. It got better in API 17, I think, with the annotation to that you have to explicitly annotate the methods that you can call from JavaScript into Java. But yeah, I haven't used that binding that much. And there's a question about what about the bootstrapping baseband firmware as a vulnerability, real or hoax? I don't know the answer to that question. Does anyone have any live questions before we sign off?
Can you compare the key store, your key store to the password key example? Have you ever used that?
Yeah. So one of the things I didn't have time to mention is since Android 3.1, there's something called the Android key store, which is kind of similar to iOS keychain in the fact that it's a kind of place where you can store a certificate. Unfortunately, it's not like the keychain on iOS is awesome because you can just store arbitrary secrets in it. On Android, you have to store like a public-private key and then use that to sort of encrypt other things. So yeah, that came in Android 4.3, and there's a couple of issues with it in terms of it sometimes not being consistent in the way it behaves. So like if the user changes their PIN on some versions of Android, it just wipes the key store, and on other times it's still there, but it still says it's there, but it actually has wiped it. So there's a bit. Actually, one of my friends wrote an article called "The Forgetful Key Store." If you Google it, he's done like a matrix of on what versions and what different things happen because he'd started using it. In terms of which is more secure, they're based on the same principle. They're using something that the user puts in that we don't store on the device to then encrypt to generate a key that we use to do the encryption. So I'd say they're roughly the same. I just prefer doing the password-based encryption internally with my app because I have control over that, and also forcing the user to put a passcode or a password in for my app when it's a secure app and there's a point to it is a kind of easy sell. But like then forcing that user to have a device PIN passcode when they don't have one, and that's the big kind of issue I find is like that's a bigger sell. Like if you're a bank, I think forcing the user to have a PIN code on their device you could probably get away with it, but other apps I think you'd really struggle with. Maybe enterprise apps you probably get away with it as well, but that's quite a big ask for the user. And just to be clear, so to use the Android key store, the user has to have a PIN code or a passcode enabled, and that's the kind of key thing. So you have to force that for the whole device rather than just your app. So that's kind of why I tend to prefer doing it in app. But it's just as good a solution as well. And also if you're in a lucky position of being able to target API 17 and above, which I don't know if anyone else is in that great situation. I know I'm not. But yeah, really good question. Cool.
Okay, one more question.
I just looked at the Seal website for this Facebook library, and they claim it's like super fast, like faster than Box. Do you work with it, or do you know like what they do, which makes it so much faster, or what it's built?
It uses I have used it, and it is pretty quick, and it uses a couple of the OpenSSL algorithms which are quick, and it uses
it's got like it's done in native code. So, but what they've done is rather than like what SQL Cipher does is bundle the whole OpenSSL library, it just bundles those algorithms and the stuff that you need. So that's kind of why it's quicker, and takes, it's not as big a payload effectively. But yes, actually worth mentioning. I kind of said in the talk, but it's one of those Facebook libraries that doesn't have the weird license about I forget what it is. But yeah, it's commercially viable. Cool. Brilliant. Well, thanks for those great questions, and yeah, cheers again for coming.